dark matter is one of the most mysterious and intriguing phenomena in the universe. It's a term used to describe an elusive substance that scientists believe makes up a significant portion of the universe's mass, yet we can't see or detect it using traditional methods. Despite years of research and study, we still know very little about this strange substance, which has led to a lot of speculation and conjecture about what it might be and what role it plays in the cosmos. At its core, dark matter is a theoretical concept. Scientists first became aware of its existence in the 1930s, when Swiss astronomer Fritz Zwicky noticed that galaxies in the Coma cluster were moving much faster than they should be based on the amount of visible matter present in the cluster. Zwicky proposed that there must be some additional, invisible matter present that was responsible for the discrepancy in movement. For many years, scientists dismissed the idea of dark matter as being too outlandish or simply not plausible. However, as technology and our understanding of the universe improved, the evidence for the existence of dark matter became more and more compelling. Today, most scientists accept that dark matter is real, even though we don't know exactly what it is. One of the most intriguing things about dark matter is that it doesn't interact with light, which is why we can't see it using traditional telescopes. Instead, scientists have had to rely on other methods to detect its presence. One such method is to observe the gravitational effects that dark matter has on visible matter. For example, we can see how galaxies are affected by the gravitational pull of dark matter, which helps us to infer its presence. Another way that scientists are trying to study dark matter is by looking for particles that are thought to make it up. One such particle is the WIMP, or weakly interacting massive particle. WIMPs are believed to be slow-moving particles that don't interact with light or normal matter, making them difficult to detect. However, there are a number of experiments underway around the world that are looking for evidence of WIMPs, which could help us to better understand the nature of dark matter. Despite our limited understanding of dark matter, scientists have been able to make some important discoveries about its role in the universe. For example, we now know that dark matter plays a key role in the formation and evolution of galaxies. Without dark matter, galaxies wouldn't have enough mass to hold together, and they would quickly dissipate into space. Scientists have also used observations of dark matter to learn more about the structure of the universe. We now know that the universe is made up of a web-like structure of dark matter and visible matter, with galaxies forming at the intersections of this cosmic web. This has helped us to better understand the large-scale structure of the universe, and how it has evolved over time. Despite these advances, there is still much we don't know about dark matter. For example, we don't know what particles make it up, or how they interact with other particles. We also don't know how dark matter is distributed throughout the universe, or whether it's evenly distributed or concentrated in certain areas. One theory that has gained a lot of traction in recent years is that dark matter is made up of a type of particle called an axion. Axions are hypothetical particles that are thought to be extremely light and weakly interacting, making them difficult to detect. However, recent experiments have shown promising signs of axion detection, which could help us to finally solve the mystery of dark matter. Another theory is that dark matter is made up of particles that are similar to neutrinos, but much heavier. These particles, called sterile neutrinos, would be difficult to detect because they would interact very weakly with other particles. However, scientists are currently conducting experiments to try and detect sterile neutrinos, and if they are successful, it could help us to better understand the nature of dark matter. There are also some more speculative theories about what dark matter could be. For example, some scientists have proposed that dark matter could be made up of small black holes, or even that it could be a new type of fundamental particle that we haven't discovered yet. Regardless of what dark matter turns out to be, its discovery and study have already had a profound impact on our understanding of the universe. It has shown us that there is much more to the universe than what we can see, and it has challenged us to think about physics and the nature of reality in new and exciting ways. One of the most exciting areas of research related to dark matter is the search for dark matter particles. There are a number of experiments underway around the world that are trying to detect dark matter particles using a variety of different methods. One such experiment is the Large Hadron Collider, LHC, at CERN in Switzerland. Although the LHC was designed primarily to study the Higgs boson and other particles in the standard model of particle physics, it has also been used to search for evidence of dark matter particles. So far, these efforts have been unsuccessful, but scientists remain optimistic that they will eventually find evidence of dark matter at the LHC. Another experiment that is looking for dark matter particles is the Cryogenic Dark Matter Search (CDMS) experiment. This experiment uses ultracold detectors to search for the small amount of heat that would be produced if a dark matter particle collided with an atom in the detector. The CDMS experiment has already placed some of the most stringent limits on the properties of dark matter particles, and it continues to search for evidence of their existence. Other experiments looking for dark matter particles include the Xenon 1T experiment in Italy, the Dark Energy Survey in Chile, and the Super CDMS experiment in the United States. All of these experiments use different methods to try and detect dark matter particles, and all of them are pushing the limits of what we know about the universe. While the search for dark matter particles is exciting, it's important to remember that even if we do find evidence of them, there is still much we won't know about dark matter. We will still need to understand how dark matter interacts with other particles and how it is distributed throughout the universe. Despite the challenges that come with studying dark matter, scientists remain optimistic about the future of this field. Advances in technology and our understanding of the universe are making it possible for us to study dark matter in new and exciting ways, and there is hope that we will eventually solve the mystery of this elusive substance. In conclusion, dark matter is one of the most intriguing and mysterious phenomena in the universe. It's a substance that scientists believe makes up a significant portion of the universe's mass, yet we can't see or detect it using traditional methods. Despite years of research and study, we still know very little about this strange substance, which has led to a lot of speculation and conjecture about what it might be and what role it plays in the cosmos. While we still have much to learn about dark matter, the study of this substance has already had a profound impact on our understanding of the universe. It has challenged us to think about physics and the nature of reality in new and exciting ways, and it has shown us that there is much more to the universe than what we can see. With new technologies and experiments on the horizon, we remain optimistic that we will continue to make important discoveries about dark matter and its role in the cosmos. Thank you for watching. If you enjoyed the video, make sure to like and subscribe to the channel. We are going to dive deep in the secrets of the cosmos and uncover the mysteries it hides.